Hi folks, welcome back. So in this series of videos, what I would like to do is look at all the problems related to parabolas in the 7 practice tests that College Board has released and identify the key skills one needs to have with respect to understanding parabolas that are needed to be able to solve these problems. So I had taken all the problems, looked at them, noted down what are the main things that you need to know about a parabola before you can solve these problems. And I've tried to do a fairly quick review here. It won't be comprehensive, as each of them, if you don't know how to do them, some of them you do have to go back and learn either from your book or through other videos. But I'll touch upon it if you already are familiar with it, so you would recognize what's needed, and also maybe a little bit of a revision. So but if you don't know at all, this won't be helpful. So you definitely need to learn this, and I'm assuming it for most people it's more of a revising what they already learned. So let's see the three different ways a quadratic equation or a parabola equation can be represented. So y equal to 2x squared plus 3x minus 2. This is an example I'll be using throughout this, and that is called the standard form. So you must be most familiar with that. Now, if you know how to factor this, it can also be written as 2x minus 1 times x plus 2. So the way the factoring works, I'm not showing you all the intermediate steps because you're going to try to find numbers, so that if you take this a and c, so if you product of these two, you have to find two numbers which when multiplied they become 4, and when added they become 3, and you split up 3 into that. For example, 3 can be split as 4 minus 1. 4 times minus 1 is minus 4, but 4 plus minus 1 is equal to 3. And after you split it, it becomes easy to uh, do the rest of the steps. So the answer would turn out to be 2x minus 1 times x plus 2. Again, as I said, if you don't know how to do factoring, learn that from other sources. So the third format is called the vertex uh, form. So this is again the same equation, just written in a different way. Y plus 25 over 8 is equal to 2 times x plus 3 over 4 square, and that also you can also bring 25 over 8 onto the right side and write it like this as shown here. So the vertex, the usefulness of each of these forms is, for example, if you write it in a factor notation, it's very easy to find out the roots or the solutions of the quadratic equation. You can see that when x is equal to half, 2x minus 1 becomes 0, so y becomes 0. Or when x is equal to minus 2, again x plus 2 becomes 0 and y becomes 0. So the two roots of the equation are x is equal to half and x is equal to minus 2, whereas the third notation makes it easy to find where the vertex is. So the vertex would be at minus 3 over 4 and minus 25 over 8. So this is the vertex. So vertex is at this point. Now let's I'm going a little slow, so let me go to the next skill that you need to know. So you need to be able to convert one to the other form. As I said, factoring is the method that you use to convert it into a factor notation, and to convert it into a vertex notation. So let's move down a bit. Not all the steps are shown, but this is the idea here. So I take my original equation y is equal to 2x squared plus 3x minus 2 and bring a out. So you can write this becomes 2 times x squared plus 3 over 2 x, and So this I can, for example, write this as 2 times x square plus 3 over 2x minus 2. And now the idea is to find a number so that the square of that will let you be able to convert it into x plus some constant square. Again, I'm not giving you a full explanation. You can go ahead and see how to complete the squares. That's something that you definitely need to know how to do. And maybe when we do one of our examples, so I can go spend more time on it. So this would turn out to be 2 times x plus 3 over 4 square minus 9 over 8, because when this comes out, minus 16 over 8, so it becomes 2 times x plus 3 over 4 square minus 25 over 8. Or you can also write the same thing by bringing 25 over 8 onto the left hand side, so you would get this equation. Now what other things do you need to know? So you need to be able to recognize when the quadratic equation has solutions and it doesn't. So a parabola or a quadratic equation can have either two roots, that is two solutions, one root, or none. So the condition is if b square minus 4ac is greater than or equal to 0, then there are real roots. It could be 1 or 2. If b square minus 4ac is equal to 0, you have exactly one root. And if b square minus 4ac is less than 0, you have no roots. That's called our complex roots. So essentially that's when the parabola doesn't really cross the x-axis. So in our example, let's see what we have. We have 2x square plus 3x minus 2. So a is equal to 2, b is equal to 3, c is equal to minus 2. Or b square minus 4ac is b is equal to 3, so b square is equal to 9 minus 4 times 2 times minus 2, you get 9 plus 16 equal to 25. 25 is greater than 0, so it has this equation that we are working with has two roots, and we had already seen that above, that x is equal to minus 2 and half are the two roots. So you need to know the standard formula. So in case you can't convert it into factors or a vertex form, you need to know this formula for the solution x1 and x2 for which y would be 0. So that is this minus b plus or minus square root of b square minus 4ac over 2a. Or in other words, the one root would be, so this would be or x1 minus b plus square root b square minus 4ac over 2a, and the second root is x2 is equal to minus b square minus 4ac over 2a. So you notice if b square minus 4ac is under a radical, if that is less than 0, we cannot really have a solution. That's the reason why the condition above holds. If b square minus 4ac is greater than 0, only then can have a solution. And if b square minus 4ac is equal to 0, then both x1 and x2 becomes the same, so that means you have only one root. So you need to know the shape of the parabola, whether it's facing up or facing down. So that's very simple actually. So if this first term a is greater than 0, the parabola faces up. If it is less than 0, it faces down. So the example that we have, 2x square plus 3x minus 2, since a is 0, it faces up. And if you look at another equation, say minus 2x square plus 3x minus 2, it will be facing downward. Okay, so you also need to have a sense of where the location of the vertex and the line of symmetry are. So in this parabola, so the two roots are x1 and x2. That is where the parabola meets the x coordinates of the points where the parabola meets the x-axis. And what's the value of the y at those points? That would be 0. You can see why it's 0, right? There is since it's on the x-axis, y is going to be 0, and that's the thing that we look for. So this is the case when b square minus 4ac is greater than 0. And our vertex, let's say, is at hk, and this is something that you need to know. The h, which is the x coordinate of the vertex, falls exactly in the middle of those two roots. So if I take x1 and x2 and take x1 plus x2 over 2, that will be equal to h. And if you plug in the value of h into your quadratic equation, let's say 2x square plus 3x minus 2, you would get the value of k, or the y coordinate of the vertex. Again, looking at the shapes, when b square minus 4ac is equal to 0, you have a parabola that just touches the x-axis, and if it is less than 0, it's going to be either completely on the top or below. So there won't be any roots, or there's no value of x for which something on the parabola is equal to 0. So another thing that's very useful to know is the sum of these two roots, x1 and x2. If we add them up, when there is a solution, it's minus b over a, and the product of the two roots is c over a. So in this case, y is equal to 2x square plus 3x minus 2. So what were our roots we had when we looked at the factor form? The two roots were half and minus 2. So if we add them up, so you get minus 3 over 2. That's also, you can also get it by minus b over a, which is b is equal to 3. So minus 3 over 2. So you can verify that this formula is correct. Same thing, you want to get the product is c over a. So in this case, c is equal to, so minus 2, right? And over a would be minus 2 by 2 is equal to minus 1. So if you multiply x1 and x2, so you would get minus 1. Oops, this is not correct. So this would be minus 1. So you need to know how to complete the squares. So we did that above, at least briefly, and you need to learn how to do that. And you also need to learn how to factor a quadratic equation. It's not always possible to factor, but in the cases where it is, you need to know that. So what do the roots represent? So in real life examples, if you're throwing a ball into the air, I'm running out of time, let me go through this quickly. So the height of the ball, if you is a y, and time if you draw time on an x-axis, x1 and x2 are the 2 points where the ball is at height 0. And if it is the revenue, as you increase the price, so initially if price is 0, the revenue would be 0, and if you increase it too high, nobody is going to buy it, so revenue would again will be equal to 0. So what's the meaning of x and y intercepts in this example? Would be if the height of the ball at time 0, or at the price when it is 0, would be the y intercept. Okay, see you in the next video.